So let's apply this to chemicals, making molecules instead of pancakes. The balanced chemical equation is like a recipe for how to make a molecule. So in this example, we have 3 hydrogen molecules and 1 nitrogen molecule, and when we put them together in the right way, we get 2 ammonia molecules. This is a lot like taking, the flour and the eggs or whatever and making the pancakes out of them. So this gives us a relationship between number of molecules. 3 molecules of hydrogen to 1 molecule of nitrogen would give us 2 molecules of ammonia. But we never do reactions that are that small because atoms are so small we can't even see them. And so that's why we use that unit mole, which is the chemist's dozen. It's just that really huge number, 6 times 10 to the 23rd things. So if it's true that 3 molecules, push the wrong button, 3 molecules of hydrogen, then it's also true that 3 moles of hydrogen. And there's no number in front of the nitrogen because chemists seem to be philosophically opposed to writing the number 1 unless they're forced to. But we understand that there's a 1 there. So this is like with the recipe for pancakes. 2 dozen eggs gets us 5 dozen pancakes. So here we're using the chemist's dozen with the chemicals. 3 moles of hydrogen and 1 mole of nitrogen gives us 2 moles of ammonia. And so just like we did a ratio between the eggs and the pancakes, we can do ratios with these chemical formulas as well. And we call these mole ratios. So we can write mole ratios between any 2 species in here. So we could say that there are 3 moles of hydrogen per 2 moles of ammonia. That's exactly like what we did with the pancakes. 2 eggs to every 5 pancakes. We can write it that way as a ratio, or we can write it as a fraction. We could say 3 moles of hydrogen per 2 moles of ammonia. Or we could flip it upside down and say 2 moles of ammonia per 3 moles of hydrogen. Those look like conversion factors, don't they? If we had, if we had 2 moles of hydrogen, how many moles of ammonia could we make? Well, 2 moles of hydrogen, it doesn't come out to be a nice even number. Let's say 6 moles of hydrogen. If we had 6 moles of hydrogen, let's write that out. 6 moles of hydrogen, and we want to know how many moles of ammonia. Well, dimensional analysis says we're going to multiply by moles of ammonia, and we're going to divide by moles of hydrogen. Because that's what we need to do to get the units to work out. If we hadn't already written out the ratios up here, we could just go look at the balanced chemical equation. There's a 3 in front of the hydrogen, so we put 3 in front of moles of hydrogen. There's a 2 in front of ammonia, so we put a 2 over here. 2 moles of ammonia for every 3 moles of hydrogen. And we do the math, and we end up with 4 moles of ammonia. Any questions? Yes?
Why do you do the hydrogen and nitrogen? Do you always do the first?
I just picked 2 of them. You could do the hydrogen to the nitrogen. You could do the nitrogen to the ammonia. You can do the ammonia to the hydrogen. You can do any combination, any 2.
On the left side.
Or the right side. Because with the pancakes, I think it was a cup of flour and 2 eggs. You could say, well, for every 1 cup of flour, I need 2 eggs. Okay, I have 5 cups of flour. How many eggs do I need? It would be 10.